Hello, this video should help you understand problem number 52 in chapter 2. I already did a rough sketch of what you should see in your textbook. It's not exact, it's basically just to help you understand what I'm looking at, then you can read the numbers off the actual book. So you have a velocity versus time graph and it's showing you the change in that velocity as you switch gears. But you're only asked to find the average acceleration for the second gear and the fourth gear. So you really only need to look at those two locations. So I'm going to show you in red for the second gear. First thing you need to do is look at the initial time and velocity. So here, this gap here, you see how it goes flat right there? That's not where second gear starts. Second gear starts where it starts to pick up. So here and here it starts, and then right before second gear goes flat, so right about here is where it ends. So in your book, you can see a clear flat section here and a flat section. Let's change it to blue. You can see a flat section there between second and third, and a flat section there between first and second. Do not calculate from the flat section, okay? Make it so that the moment that it starts to go up, that's where you're looking at, and the moment where it starts to go flat at the end is the end, okay? Um, so with the fourth gear, it's a little different. You have a point here where fourth and fifth are connected. That's the end that you would look at there. I need to make that brighter. There you go. So that's the end there, and this is the beginning for fourth right here. Okay, so actually I think that might make it a little easier to see. So here, that's the end of second, and this is the beginning of second. So what I'm going to do now is give you the values that I found, and then you can look at the data table yourself, or sorry, the graph yourself and take a look. But I just go straight down like that, straight down like, whoops, straight down like this, and over. Oof, sorry, this is not, whoops, not as straight as I would like it to be. Oh, that's not good. Can't undo that, can I? Huh. Alright, guess I'll just draw that again quickly. I'll just draw the parts that we needed. This went down like this, and this part was like that. There was a straight section that went like this, and third gear had a flat section as well, and then went down like that. Yeah, that wasn't so bad. This was fourth gear. Now, I was drawing this horizontal section here. You just need to know the values in the X and Y for those light blue points, okay, which you're having trouble seeing now because I drew over it. So this point, that's light blue. This point, that's light blue. This point, and this point. And I'm going to just label the points that I identified. So the velocity, that's way too thick. The velocity for the second gear, initially, I identified at positive 14 meters per second. And it's okay if you have it a little bit off, okay? It's going to be within a meter or so. And then I had the velocity for the second gear at the end at a positive 24 meters per second. I said that the time for second gear to start was 4 seconds, and the time for the second gear at the end was 8 seconds, and you don't know the acceleration for the second gear, that's what you're trying to find. Okay, very basic. You end up just taking a look at the acceleration equals the change in velocity over the change in time. So you just do final minus initial divided by final for the velocity divided by final minus the initial for your time. Okay, I don't think if you got this wrong it's because of the math. I think it's probably because you just read the graph a little differently. So that's why I'm just going to give you the values. I'm not going to bother plugging in the actual numbers. So that was for second gear. For fourth gear, I said that the velocity for fourth gear initially was a positive 36 meters per second, and that the velocity for the fourth gear at the end was a positive 45 meters per second. The time for the fourth gear initially was 16 seconds, and the the time for the fourth gear at the end was 27 seconds. You use the same equation for both, you're just plugging in different values, okay? The acceleration for A, the second gear, was, I'm going to highlight it to make it easier for you to follow. So if you take these values, then your answer for A you get A to equal, that looks like a weird A to equal a positive 2.5 meters per second squared. And if you do for the fourth gear, which I just realized I forgot to draw or write out here, A4 equals a question mark. For fourth gear, you're going to have A equals a positive 0.82 meters per second squared. Now keep in mind, you're going to be boxing these, so put A4 with a subscript in your answer there, and A2 in your subscript over here, so that way it's clear which answers are which, and box them. Okay, so when I look at your homework, it should look like this. You should have a box around it so I know what your answers are. Makes it easier to locate answers for messy situations. Now you're not graded on your answers, but I like to check the answers to see how many students are getting answers incorrect and how many are getting them correct. Now that's just for part A of the problem. The next part, you have to figure out the distance traveled just in the fourth gear. Okay, so you actually don't need to use the second gear at all in this problem. You just need to be able to realize that, sorry, I didn't want to zoom out that far. You just need to be able to realize that you can figure out the average velocity, V average, for fourth gear by taking the final velocity, so V4, that's the final velocity for fourth gear, plus the initial velocity for fourth gear, all divided by 2. When you do that, it's going to equal well, you're going to plug in the values 45 meters per second plus 36 meters per second, all divided by 2. So you're going to get an average of a positive 40.5 meters per second. Now that velocity is needed in order to find out the distance, okay, because you're going to use velocity equals delta x over delta t. You already know the delta t because you know that you had 27 seconds for your final, 16 seconds for your initial, so that's 11. So basically we're going to multiply the time over to the left, so you're going to have delta x equals v times delta t. So using this as your v, you plug that in here, and t is just your change that you had already from T4 initial and T4 final. I'm going to go ahead and do this over here on the bottom. Okay, I'm just going to scroll up a little bit. We'll have delta x. Now keep in mind this is actually changing x while in fourth gear, so you can use a subscript of a 4 will equal v average for fourth gear multiplied by the change in time for fourth gear. So that's how you would rewrite the equation, so it's applied to fourth gear. Plugging in the values, you get delta x in fourth gear equals positive 40.5 meters per second times 27 seconds minus 16 seconds. And your answer will be that delta x equals a positive 445.5 meters, which with 2 sig figs, because none of the values I received from the graph have more than 2 sig figs, would be positive 450 meters, and that would be your answer. Okay, you would explain your answer in a few sentences, explain that you identified the locations where the second gear started and second gear ended, not at the transition between gears, to get a most accurate representation of those points. Once you've done that, you can use the basic kinematic equations, basically using the definition of acceleration and the definition of velocity to both measure the acceleration, the average acceleration, and the estimation of how far you'd go in fourth gear. Okay, so really pretty basic. It's just a matter of being able to read that graph, which I admit can be kind of tricky with that flat, especially if you guys have never driven a stick shift. That flat section might be confusing for you, but basically that flat section is you're transitioning from one gear to the next, so it's not actually counted as part of the gear because you're not having a transition there. As far as the velocity is not changing, it's staying constant from before, so you don't need to include that in your time calculation for going from second to going to third. Okay, so you don't need to use that in your time. If you use that in your time, it changes the average acceleration by quite a bit, because you're saying it takes longer time to have that transition in the velocity than it really does. But other than that, it should be easy for you to go through the equation. So you probably got a number that was close to mine but not exact, and if that was the case, it's just because you got a slightly different time variable.